welcome to another mathematics presentation. So in this presentation, we are looking at circle theorems, which is a grade 11 topic. So under this topic, we are going to look at properties of the circle, where we are going to analyze the parts of the circle. Then we are also going to look at the angle properties, where we are going to solve problems using angle properties of the circle. We are also going to solve problems involving tangent properties. So let's look at these parts. Right? We are going to define what a circle is. So a circle is defined as a set of points which are all the same distance from a given fixed point. So a circle, it includes a set of points, and these points, they have the same distance from the fixed point. And that fixed point, okay, we are calling it the center of the what? Of the circle. So let's look at the diagram here. We have this center of the circle, and this is called the center of the circle. Okay, so this is what a circle is. So let us now move on. We look at other parts such as the diameter and the radius. So let's take a look at these two diagrams. So we have the first diagram, which is on the right hand side here, where we have the diameter right here. So this is the diameter of the circle, and this diameter cuts the circle into two equal parts. So this diameter has to pass through the center of the circle. So this diameter now, once it cuts the circle into two equal parts, it will form what we call a semicircle, which is half of the what? Half of the circle. Okay. Again, on the other hand, if you draw a line from the center of the circle coming through and touch the what? The circumference, this line will be called the radius of the circle. So what we are saying is that the diameter is 2 times the radius, and diameter cuts the circle into two equal parts, and it will form one part which we call the what? The semicircle. So we are saying diameter is the width of the circle that passes through the what? The center. Okay, and on the other hand, we can say radius is the distance from the center to the circumference. So the radius has to start from end point of the circumference and coming through the what? The center. This is what we are calling the radius. So we now move on and we look at other parts of the circle. So here we are going to look at these other parts, where we have the sector of the circle, and you have the semicircle. We also have the quadrant. So the sector, this one is formed by two radii, okay, and this is the semicircle, and this is the quadrant. So I've explained on the semicircle. Okay, we now move on. We look at other parts of the circle, where we have the circumference. So a circumference, this is the circumference here, which is just the outer line right here, this outer line. So the circumference of the circle is the total distance around the what? The circle. That is what the circumference is. So circumference of the circle is the total distance around the edge of the what? Of the circle. And this circumference can also be calculated by using this formula, which is circumference is equal to 2 pi r, meaning 2 times the pi. The pi will be given, which can either be 7 over 22, or it can be 3.142. Okay, so this is what the circumference of the circle is. We now move on. We look at other parts of the circle, where we have the chord and the arc. So this is the chord right here. So whenever you draw a line starting from the circumference of the circle and coming to the other circumference of the circle without passing through the center, this is the line that we call the what? The chord. Okay, so we are saying a chord is the line joining 2 points on the circumference. Okay, this is the chord, and this chord can be drawn from anywhere. It can be drawn from here up to here. Okay, it can also be drawn from here up to here. It can also be drawn from here up to here, as long as it's not passing through the what? The center. Okay, the line that will only pass through the center, that is the diameter of the circle, and you also can connect the radius of the circle. So this is what the chord is. Then you can see right here, we also have an arc. Okay, we also have an arc. So an arc is just a fraction of the what? Of the circumference. So this is the minor arc, and this is the major arc right here. Okay, so this is what the chord and the arc is. So we now move on. We look at a segment. So a segment here is formed when we draw the chord. So once we draw the chord, we are going to have a minor segment, which is this part. Okay, so a segment is just the area enclosed by a chord and an arc. So here we have the minor segment, and this side here are going to have the major segment. So I hope you are understanding these parts of the what? Of the circle. So we now move on. Let us look at a tangent to a circle. So a tangent is a straight line that touches the circle. So you can see we have this line L, okay, which is just touching on the what? The circle. So the tangent and the radius right here, the tangent and this radius from this point P up to point O, they are forming a right angle right here. This is another property of angles that you must know. So I have said a tangent is a line, okay, that touches the circumference at one point of the circle. This is the tangent. So let us look at other parts. So this is the tangent, is just touching the circle outside. Then we have another line which can touch or which can pass through the circle inside, okay. It can pass through and penetrate through the circumference. This line we call it a secant. So here we can also have another line which is a secant. Okay, it's also not passing through the center. So we now move on. We look at other parts of the circle. We have said we have the chord right here. We also have the diameter. We have the radius. We have the secant, and we also have the tangent. This is the summary of parts of the circle. So I hope it's clear. So let us now look at the circle theorems. So we have different circle theorems, and these circle theorems, they help us to be able to solve problems using angle properties of the circle. They can also help us to solve problems involving tangent properties. So the first circle theorem that we are going to look at, it's the angle which an arc subtends at the center of a circle is twice that which subtends at any point on the circumference. Okay, this is the circle property or the angle property. Another property we're going to look at is an angle in a same circle is a right angle. I'll show you diagrams for these circle theorems. Another theorem we're going to look at is an angle in the same segment of a circle are equal. Okay, angles in the same segment of a circle are equal. Another property that we're going to look at is the opposite angles of a cyclic quadrilateral add up to 180 degrees. Another circle theorem we're going to look at is the exterior angle of a cyclic quadrilateral is equal to the interior opposite angles. Very important to take note of these circle theorems, okay? Very, very important. So let us look at our first theorem, which is angle at the center. So let's look at the diagram right here. We are saying the angle at the center is twice the angle at the circumference. So when you look at the diagram right here, we have this center right here. On the center, we have the angle which is 2x. Okay, so right here we have this angle 2x, and on the circumference we have this angle which is what? X. So we are saying the angle which is right here at the center is 2 times bigger than the angle which is on the circumference. So an example is that if on the circumference we have, let's say you have 4 degrees, okay, at the center you are going to have 80 degrees, because we are saying the angle on the center is 2 times bigger than the angle on the circumference. So I hope this property is clear. So let us look at an example. So for example, if you have this example right here, they are saying find theta. So this theta is the angle which is on the what? Which is on the center, and you have the angle which is on the circumference right here. So the angle on the circumference is 40 degrees, and the angle at the center we have a theta. So how can we find the value of theta? So to find the value of theta, we are saying the angle which is at the center is 2 times bigger than the angle on the circumference. So if on the circumference we have 40 degrees, it means that the angle which is at the center should be 2 times bigger than the angle on the what? On the circumference. So I'm going to say theta equal to 2 times the angle which is on the circumference, which is 40 degrees. And this will give us theta is equal to 2 times 40 degrees to give us what? 80 degrees. So this is our answer, meaning that right here the angle is 80 degrees. I hope this is clear. Okay, I hope this is clear. So If you have any questions, you are free to leave a comment in the comment section. I'll be able to respond to you. So let us look at another example. So this is the second example where we have been told to find the theta. Now in this case, the theta that we are referring to is this angle right here. So here we have an angle which is what? X. And here we have an angle which is 126 degrees. So the angle that we want to find, okay, is the angle which is on the circumference. And here we have been given the angle which is on the angle at the center, which is 126. So to find the angle on the circumference, we know the property that we are looking at is the angle at the center, and we are saying the angle at the center is 2 times bigger than, okay, the angle on the circumference. So to find this angle x, we are going to say angle x is equal to, we get 126 degrees, then here we are going to divide by what? By 2, because this angle which is at the center is 2 times bigger than the angle on the circumference. That's why we are dividing, okay? So I'm going to say angle x is equal to, so 2 here 1, 2 into 12, it's 6. Again, 2 into 6, it's a 3. So 2 into 126 goes there many times? 63 times. So the value of angle x is a 63 degrees. I hope this is clear, okay? I hope this is clear. So make sure that you know these properties. The angle at the center is 2 times bigger than the angle on the circumference. So if you are finding the angle which is on the circumference, you just need to divide by the angle which is at the center. If you are finding the angle at the center, you just need to multiply the angle which is on the circumference with a 2. That's when you are going to get the angle on the center. I hope this property is clear. So let us now move on. We look at another property. So this property is theorem 2, where we are saying angle in a semicircle. So remember what I said about the semicircle? I didn't mention that if the diameter cuts the circle, it will form a semicircle like this. Now in this semicircle, we can have a chord like here, even here a chord, and the right here again have a 90 degrees. So let's say we have A, B, C. So when we say A, C, B, the angle which is right here on C will be a 90 degrees. So this is the property that we are looking at. Okay, this is the property that we are looking at, and I hope it's clear. So we are saying the angle in a semicircle is always a 90 degrees. So we can take a look here. We have the diameter AB, then we have the chord BC, we also have another chord AC. So right here on C, that is where we are forming a 90 degrees. Okay, so this property is also very important. Okay, so you can also look at this. This is what I've explained. Angles in a semicircle where you have AB, diameter, and the right here you have a 90 degrees. So angles in a semicircle or subtended by the diameter, it gives us a what? A 90 degrees. So let us look at the example. Find angle y. So here we have an angle right here, which is angle y, and we need to find this what? This angle. So how do we find this angle y, which is right here? So to find angle y, we know that here we have a diameter. This is a diameter. Okay, we have a diameter right here. This is a diameter. So we have a chord right here, which is touching the circumference, another chord touching the circumference. So the angle that will be subtended now from this diameter, we have a 90 degrees right there. So here, inside here, we are going to have a 90 degrees. And when you look at what we have something like this. Okay, you have something like this. And this is a right angle. So if here you have y, and here you have 33 degrees. And you need to find the value of angle y. So the sum of angles in a triangle adds up to what? 180 degrees. So I'm just going to add y plus 33 degrees, then plus 90 degrees. And this will give us 180 degrees. Because the sum of angles in any triangle, it adds up to 180. That's why we have added. Okay. So from here we can say y plus, now 3 plus 0 is a 3. 3 plus 9 to give us a 12. So the 3 plus 90 gives us 123 degrees. which will be equated to 180 degrees. So from here we can take 123 degrees to the right hand side. We have y is equal to 180 degrees, take away 123 degrees. So from here we can have y equal to, so 0 minus 3, it can't, you borrow a 1 from 8, we have 10 minus 3 to give us a 7, then 7 minus 2 to give us a 5. So 180 minus 123 to give us 57 degrees. So the value of y is a 57 degrees, meaning that here we had a 57 degrees. So I hope this property is very easy. You have understood it, okay? So if you have any questions, feel free to leave those questions in the comment section. I'll be able to respond to you, okay? So we can look at another example right here. This, maybe let's say this one, you can try it out. This one right here, you have this circle and you have the diameter BC, then you have chord AC and the chord AB. You have VAX and you have VA4X. So you need to find what? X, okay? You need to find the X. So find angle X. So you need to find the value of this angle right here, which is X. So this one you can try it out, okay? You can try it out. You can pause the video. Once you are done, then you can see how the correct answer is. So to find the value of X now, what you are going to do is, to find the value of X, what you are going to do is, since what you have here, we have the angles in a semicircle, okay, which is a 90 degrees. So a 90 degrees will be formed right here, okay? This is where we have a 90 degrees. So we know that the sum of angles in a triangle is 180. So I'm just going to add 4x plus x plus 90 and we equate to 180. So we are going to have x, then plus 4x, again we add with a 90 and is equal to 180 degrees. So this is a 90 right here, because we are saying angles in a semicircle is always a 90 degrees. So this is a semicircle that we have this side. So it's forming a 90 degrees right here on point A. So x plus 4x, here we are going to get a 5x, okay? Then plus 90 degrees is equal to 180 degrees. So we are going to have 5x is equal to 180 degrees, take away 90 degrees. So 90 degrees was a positive, when it goes to the right hand side becomes a negative. So we have 5x is equal to 180 degrees minus 90 degrees. This will give us a 90 degrees. So we need to find the value of x. So we divide by 5. Even this side we divide by 5, so that we remain with the x on the left hand side. 5 and 5 will cancel. We have x is equal to, so 5 here 1, 5 into 9, it's a 1. Remainder a 4. Remember this is paper 1, so no need of using a calculator. 5 into 40, it's 8. Okay, 5 into 40, it's 8. So meaning that 5 into 90 goes there 18 times. So the value of x is equal to 18 degrees. So right here we had 18 degrees, and right here, since we have 4x, so we need to multiply 4 times 18, and 4 times 8 will give us 32. We write 2, we carry 3. 4 times 1 is 4, plus that 3 is 7. So here we had a 72 degrees, and here we have a 90 degrees. Okay, that is how you can answer this question. I hope it's clear. We have understood this property. So we can now proceed. We move on. Okay, so let us go to theorem 3. Now this theorem 3, we are looking at angles in the same segment. Angles in the same segment. So this property states that angles in the same segment are equal. So how are we forming these same segments? We are drawing a chord from this circumference up to the other circumference. Again, we extend. Okay, we extend through. This is the diameter. Okay, again this is diameter. So extend. So what we are saying is that the angle which is right here at A is equal to this. So now they are saying angle A is equal to angle A. So if here you have a 40 degrees, even here you have a 40 degrees, because we are looking at angles in the same segment. Okay, they are lying in the same segment. You can see here we have this circumference right here. So these angles are lying in the same segment, coming from the same chord. Okay, again, this angle and this angle, they are also equal, meaning that angle B is also equal to angle B. So if here you are having a 63 degrees, even here it will be 63 degrees. So this property is very easy to understand. Okay, angles in the same segment are what? Are equal. Angles in the same segment are equal. Okay, so very important to understand this property. Again, sometimes you may be given this one. Okay, you may be given this one. Again, you can see from here we have this chord right here, another chord right here, another chord, another chord. So again, we have the same property, angles in the same segment. So this angle and this angle right here, they are the same. So if here you have angle X, even you are going to have angle X. This is very, very important. Okay, so let us now look at another example. So find theta. So here we have angles in the same segment. We have the theta right here. Okay, so this segment, this angle right here and this angle right here, they are the same. So just say theta is equal to 30 degrees. So if you have a 30, even you have a 30 degrees. Very, very important. Okay, very, very important to understand this principle. Okay, let us now move on. Okay, so we come to theorem 4, where we are looking at cyclic quadrilateral. Cyclic quadrilateral. So angles in a cyclic quadrilateral add up to what? 180. Angles in a cyclic quadrilateral add up to 180. So when you look at this circle right here, we have a chord AG, another chord GC, another chord BC, another chord AB. So what we have right here, this is a cyclic quadrilateral. Okay, serving 4 angles. This is a cyclic quadrilateral. So the opposite angles of a cyclic quadrilateral add up to 180. So the opposite of this So the opposite of this angle A right here is the angle C. Okay, so when we add, we say angle A plus angle C, this would give us 180 degrees because these are opposite angles. Another opposite angle, we are looking at angle D, okay, where we add with angle B. Again, this one should give us 180 degrees. So this is how we answer such type of questions. So this is another property which is very important. Opposite angles add up to 180, and these opposite angles are only angles that are in a cyclic quadrilateral. Okay, so now which one are we considering a cyclic quadrilateral? So here, don't make a mistake. If you are presented with something like this, you have a circle right here, and it's passing like this. Okay, here, and then you say this angle and this angle are opposite, this and this are opposite. No, it has to touch the circumference. Okay, this has to touch the circumference, and this one also has to touch the circumference like this. Okay, make sure you understand this. Okay, very, very important. So let us now look at another diagram. So we are saying a cyclic quadrilateral has all its vertices on the circumference of the circle. This is the cyclic quadrilateral. Okay, opposite angles add up to 180. This is what I've explained. So angle A is opposite to angle C. Okay, angle A and angle C, they will give us 180. Angle B and angle D, they also give us 180. Now, there is something that I want you to focus on. You can see we have this is the chord. Now you can see it has extended up to here. Then you can see from here we have an angle which is angle E. So this angle E is an exterior angle. So what you are saying is that exterior angle is equal to the interior opposite angle. So this angle E, its interior opposite angle is angle A. So we are saying angle A is equal to angle E. So this is another property that I've combined with the cyclic quadrilateral. So the exterior angle, which is angle E right here, is equal to the opposite interior angle of the cyclic quadrilateral. So angle A is equal to angle E. This is very important. Take note. So if here you have, let's say 35 degrees, Even here on E, you are going to have a 35 degrees. Give a reason. The reason is simple. This is a cyclic quadrilateral, and the exterior angle is equal to the interior opposite angle. Very important to understand this property as well. Okay, so let us look at an example. So this is the example where we have this question: find angle x and angle y. So here we have angle y. The opposite of angle y is a 63, and here we have angle x. The opposite of angle x is a 104. So how do we find the angle y? So you know that these two are opposite to each other, and they add up to 180. So to find the angle y, you say y plus 63 degrees is equal to 180 degrees. So I'll take 63 that side. You are going to have y equal to 180 degrees. Take away 63 degrees. Okay, so I have y equal to 180 degrees minus 63. So 10 minus 7, 3, it's a 7. 7 minus 6, it's a 1. 1 minus nothing there, it's a 1. So this will give us y is equal to 117. So this is the value of angle y. Okay, so meaning that right here there was 117 degrees, such that when we add 117 degrees plus 63 degrees, we are going to get a 180 degrees. Okay, then how can we find angle x right here? So again, 104 degrees is opposite to angle x, because these are angles that are in a cyclic quadrilateral. So when we add x plus 104 degrees should also add up to 180 degrees. So 104 degrees will go to where 180 is. We are going to have x is equal to 180 degrees, take away 104 degrees. So x is equal to 180 minus 104. So 10 minus 4, it's a 6. 7 minus 0, it's a 7. Okay, so 1 minus 1 is a 0. So this will give us 76 degrees. Meaning that right here where there is x, there was a 76 degrees. So when you add 104 degrees plus 76 degrees, you are going to get 180 degrees, because these are opposite angles of a cyclic quadrilateral, which adds up to 180 degrees. I hope these theorems are very, very clear. Okay, so let us now move on. We look at theorem 5, where we are focusing on the tangent and the radius. So we are focusing on the tangent and the radius. So this theorem says tangent and radius, they meet at 90 degrees. So if you did pay attention when I was explaining on the parts of the circle, I did mention that here if you have the tangent, because the tangent is a straight line that just touches the what? The circumference of the circle. So this tangent is just touching the circumference of the circle at this point. And here we have a radius here. So this radius and this tangent, they are meeting at an angle of a 90 degrees. So we can see that here we have a right angle which is a 90 degrees. Okay, we have a 90 degrees. So this is a 90 degrees. So this is another property that you must know, which is very, very important, and this is our theorem 5. Okay, so we can also look at the other diagram right here. Okay, we still have the tangents. So AC is a tangent. Again, BC is also a tangent. So meaning that the length of AC and the length of BC, they are the same. That's why you are able to see this mark and this mark right here. Meaning that tangent AC is equal to tangent what? BC. Okay, so what we are saying is that the angle which is right here is a 90, and the angle which is right here is a 90. Okay, I hope this is clear, because here we have a radius, again here we have a radius. So this is very, very important for you to understand. Okay, so this property, take it into consideration. It's very important. So let's look at an example. So this is our example. The question reads, in the diagram alongside this diagram right here, O is the center of the circle, and PT and QT are tangents to the circle. So PT, okay, we have PT, then we also have QT. So PT and QT, these are tangents to the circle. Okay. Question A, if angle POX. So here we have angle POX. POX right here. So the angle which is right here is 61 degrees. Okay. So calculate the size of angle QTX. Calculate the size of angle QTX. So they want us to find this angle right here. They want us to find this angle because they are saying you need to find the angle QTX. Okay. All right. Sorry, not this angle. QTX. QTX. This angle right here. This angle. This is the angle they want us to find, not this angle right there. So I hope you are following. Make sure you follow through. So they want us to find this angle right here because they have said QTX. So here we have been given that POX, the angle on O, POX, this angle right here, we have that we have been given that is 61 degrees. Okay, now we must know that PT is a tangent, QT is also a what? A tangent. Then OQ, this is a what? A radius. Okay, which is meeting with the it's meeting with tangent what? QT, and it's meeting at, or it's forming a 90 degrees. So right here we have a 90, same here, even here. Okay, we have a 90 degrees. So very important to understand these principles. Very important. So now how can we find the angle QTX? How can we find the angle right here on Q? So to find the angle on Q, this one is very easy. Okay, to find the angle on Q, we can, there are many methods that you can use. There are many methods that you can use. If you want, you can consider, this OQT, this triangle right here. You can consider it, okay, if you want. Okay, again, if you don't want, you can also consider other triangles. So let's see the appropriate method that we are going to use. So we can now find the angle QTX. This is the angle you need to find, the angle on T. QTX, the angle which is right here. So to find the angle which is right here, we can see we have the radius right here, which is OP. So this radius OP is perpendicular to the tangent PT, meaning that here we are having a 90 degrees. We are having a 90 degrees. Then we have been given that POX, here we have a 61 degrees. I hope you are following. So if we have POX, we have a 61 degrees. Then we can say, therefore, angle PTO. Angle PTO. The angle which is right here. Because the angle which is here, once we find the angle which is here, it will be the same with the angle which is here. Why are we saying this? Because we know that this triangle POT is equivalent to triangle OQT. Okay? It's equal. So this angle and this angle will be the same. So let's find this angle first. So to find this angle, remember here we have a 61 and here we have, this is a 90. So you need to find it here. The sum of angles in a triangle is 180. So you say 180 degrees minus the sum of 90 degrees plus 61 degrees. So this will give us angle PTO equal to 180 degrees minus. So 0 plus 1, it's a 1. 9 plus 6 to give us 15. So this will be 151 degrees. So therefore angle PTO equal to, so 180 minus 151. 10 minus 1, it's a 9. 7 minus 5, it's a 2. 1 minus 1 is 0. So this angle is a 29. So here we have a 29 degrees. Now from here we can make conclusions such that I've said that this triangle, okay, triangle OPT is equal or is equivalent to triangle OQT. So this triangle OPT, okay, is equivalent to triangle OQT, because even here we have this radius OQ, which is perpendicular to the tangent QT. So even here there is a 90. That's why I'm saying this and this are equivalent to each other because of these properties that I've mentioned. So from there we can notice that this angle QTO, okay, angle QTO, okay, this angle QTO will be equal to this angle PTO, okay. And which one is angle PTO? This is the angle that you have found. So this, we can say that therefore angle QTX is equal to angle PTO. So this will say therefore angle QTX is equal to, what is angle PTO? We found that it's a 29 degrees. So this is our answer, that even here there is a 29 degrees. As simple as that. So make sure that you follow these steps that I've mentioned. You pause the video, you go through. Okay, very, very important. So I've come to the end of our short presentation under circle theorems. Make sure that you go through everything, you learn what I've presented. And thank you so much, everybody. If you have any questions, you are free to leave a comment in the comment section. I'll be able to respond to you. This has been your presenter, Mr. Mlenga. Bye-bye.